Oh, welcome. This is lesson 3.4 on factoring quadratics when the leading coefficient is not 1, and that refers to um, this ax squared plus bx plus c when a is some number that's not 1. So you have 3 or 7 or negative 2 or something there in a that's not just x squared. So for those that are just x squared, you can refer back to the video on 3.3 over factoring that sort of trinomial. Okay, I didn't include this here in the notes, but I wanted to say the first thing you should do is always check for greatest common factor first. If there is a greatest common factor, you want to factor that out, and then you can, with whatever's left, take a look to see if you can use another factoring strategy such as this one that we're going to learn today. So number one, make sure your expression is in standard form in decreasing order. This is degree 2, degree 1, and then 0. So it's in decreasing order by exponents. Then take a, your coefficient of your x squared term, and your c, which is your constant term, and multiply them together. Then find, so that's this first one, and then the second one, multiply, find a times c, and then find two numbers, we'll call them p and q, such that p times q equals ac, a times c, and p plus q equals b. Once you found those two numbers, you can do one of two things. Either use the box method, put them in a box, like so, using p and x. P and q to write the numbers px and qx. Ax squared stays the same, c stays the same. Or rewrite your b term, your middle term, using p and q. So I've got bx is equal to, since p plus q equals b, px plus qx equals bx. And so you can rewrite that ax squared plus bx plus c as a polynomial with 4 terms, and then you can just factor by grouping, as we have seen before. You would take that, and let's look at an example of that right now. So 2x squared plus 9x plus 4, and I see that there isn't a greatest common factor. 2 won't go into 9 without a remainder, and they don't all have an x, and so there is not one greatest common factor amongst all 3 terms. So when we just find a times c, ac equals 2 times 4, 8, and b equals 9. And so we're looking for two numbers that multiply to give us ac. So I'm going to put a little time sign to remember we're multiplying to find ac, and that add to give us the b, which is 9. It's the middle term, the coefficient of the middle term. So I just always start with 1. 1 times 8 equals 8, and 1 plus 8 equals 9. So right off the bat, we found the numbers that we're looking for. So we're going to then rewrite this 2x squared plus 9x plus 4, and we're going to rewrite it as 2x squared. This first thing stays the same, plus 1x plus 8x plus 4. And so we'll notice, what I'd like you to notice here is that the first terms, and the last term stay the same. That plus 4 and that 2x squared, they're the same as they were before. But the 9x in the middle, we rewrote using the two numbers we found, 1x and 8x. 1x plus 8x is 9x. And so then we have factored this by grouping. 2x squared plus 1x plus 8x plus 4. And I'm going to factor out what they have in common in each group. So 2x squared plus 1x share an x. And when I take those out, I get 2x plus 1. And 8x plus 4, they have a 4 in common. So take out 4 times 2x plus 1. And that's what we're looking for. We're looking for this term right here in the middle to be the same, or the binomial term to be the same. And it is 2x plus 1. And so we can factor that out. And we get 2x plus 1 times x on the one side and 4 on the other side. So we put plus 4. And we end up with 2x plus 1 times x plus 4, and that is how this one gets factored. All right, let's take a look at number 2. We'll do one with the box. So again, first thing we want to check for is 3n squared plus 13n minus 10. None of them have a common factor. 13 is prime, 3 is prime, and so they don't share a common factor. So we'll look at this and say, okay, AC, A is 3 and C is negative 10, and so AC is negative 30. And B is 13. So we're looking for two numbers that multiply to negative 30 and that add to our middle term 13. And so I usually start with 1 times 30. Now, I need to put a negative on there because only with one number positive, one number negative being multiplied will you get a negative result. But since 13 is positive, I'm going to put the negative on the smaller number. Negative 1 times 30 is negative 30. Negative 1 plus 30 is positive 29. Now, those are not the numbers we're looking for because it needs to add to 13. And these two combine to give us 29. But we do have the sign in the right space on a larger number. So I'm going to put negative 2 times 15, and that would be negative 30. Negative 2 plus 15 is 13. Those are the numbers that we're looking for. Okay, so we're then going to take our original trinomial here, and we're going to rewrite it in the box. We're going to take the first term, 3n squared, and put it in the first box. We're going to take minus 10 and put it in the last box. But for the 13n, we're going to use those two numbers that we found. We're going to put minus 2n and plus 15n. And 15n minus 2n is 13n. So everything in the trinomial there is represented in the box. So we've got 3n squared minus 2n have an n in common. And 15n minus 10 have a 5 in common. So we're going to put 5. 3n squared and 15n have 3n in common. And minus 2n and minus 10 have 2 in common. But since they're both negative, we're going to put minus 2. So before I write the factors that I've got here, I want to make sure that they multiply out to give me what I need here. 3n times n. 3n times n is 3n squared. N times minus 2 is minus 2n. 3n times 5 is plus 15n. And 5 times a negative 2 is a negative 10. So it works, including with the signs. And I've checked. So now I know that my factors are 3n minus 2 times n plus 5. And that's factored. All right, example 3. 10x squared minus 24x plus 14. Now here I see that they're all even, and so I can factor out a 2 as the greatest common factor. So I'm going to first rewrite this as 2 times 5x squared minus 12x plus 7. And then I'm going to take a times c, but using the trinomial inside the box. So this 2 outside, I factored that out. I'm going to leave it out there until I get to the end. And so AC, again, this being A and this being C, 5 times 7 is 35. And B is negative 12. So I'm going to take 35 and just make note that I'm multiplying to 35 and negative 12. And again, I'm going to make note that I'm adding to get negative 12. Now, there's two numbers. 35 is a positive number. So I can only get that by multiplying either a positive times a positive or negative times a negative. But since B is negative, it's negative 12, that means both numbers have to be negative. So I'm going to start with negative 1 times negative 35. And then I add those together, I get negative 36. Now, those are not my numbers. And then 2 will not go into 35 because it's not even. 3 won't go into 35. 3 plus 5 is 8, and 8 is not divisible by 3, so 35 is not divisible by 3. 4, again, 35 is not even, so 4 won't go in there, but 5 will. And so we're going to put 5 times 7, and once again make both of them negative. So negative 5 times negative 7 is positive 35. Negative 5 plus negative 7 is negative 12. So those are the numbers that we're looking for. So I'm going to rewrite this original expression here as 2 times, I'm going to change the parentheses to brackets for just a moment here and put 5x squared minus 5x minus 7x and plus 7. And these two minus 7x, minus 5x and minus 7x are this minus 12x. And they came from the numbers that we found when we multiplied together minus 5 times minus 7 to get 35. But they equal that minus 12x. And so now we've broken this into 4 terms. I'm going to use a box for the inside of this. And I'm going to put 5x squared here plus 7 minus 5x minus 7x. And then I'm going to factor by greatest common factor for each row and each column. 5x squared and minus 5x both have a 5x in common. Negative 7x and plus 7 both have a 7 in common. 5x squared and minus 7x in this column here have x in common. And minus 5x and 7 don't apparently have any factors in common, but remember that if they don't have any factors in common, they always have 1 in common. Now, I didn't put the signs on because I want to make sure that I'm getting them correct. You, generally speaking, don't want to have your first terms be negative. So we're going to leave the negatives off of those, which means we need to have this one be negative and this one be negative. And then I just want to double check to make sure 5x times x is 5x squared. Yes, 5x times negative 1 is negative 5x. X times negative 7 is negative 7x. And a negative 7 times a negative 1 is a positive 7. So those work out all right. Now, I'm going to take these factors out. X minus 1 times 5x minus 7. And last but not least, don't forget that 2 that we factored out in front, it needs to be added in here as a factor also, so we just put a 2 out in front. And this is our factored form, 2 times x minus 1 times 5x minus 7. All right, finally, number 4. These have a 3 in common. So I'm going to take 3 times 2y squared minus 13y plus 15. After you factor the 3 out of each of those terms, that's what you're left with. AC then is equal to 2 times 15, or 30, and B, our middle term, is negative 13. So I'm going to write 30 in a little box here. Multiply. Remember, we're multiplying for that 30. And B is 13. So negative 13. And we're going to add to that. So that means both numbers have to be positive. Both numbers have to be negative to get 13. To get negative 13, excuse me. So negative 1 times negative 30 would be negative 31. That's not it. Negative 2 times negative 15 would be positive 30, and negative 2 plus negative 15 would be negative 17. Neither of these are it because they're not equal to negative 13. Negative 3 times negative 10 would give me positive 30, and negative 3 plus negative 10 is negative 13. So those are the numbers that we're looking for. So this time I'm going to factor by grouping. So we're going to take 6y squared. Oops, nope, sorry. We're going to take it and write it like this. 3 times 2y squared. And once again, I think it was good to put a bracket in there. 2y squared minus 3y minus 10y plus 15. Close the brackets. Okay, now when I'm grouping them, the first two terms, no problem, 2y squared minus 3y, I just put some parentheses around them. But when I put the parentheses around the last two, you have to be careful not to put that negative in front of the 10y outside of the parentheses. So we're going to add a plus sign and then put parentheses, minus 10y plus 15. Close the parentheses. Now we've got 3, and this 3 is just hanging out outside. You know, we're just waiting for us to do something with it. In fact, we're not going to do anything with it. We're just going to add it to our list of factors once we're done. And then we've got parentheses. 2y squared and minus 3y have a y in common. So take the y out. We're left with 2y minus 3. Negative 10y plus 15. When you have a negative as your leading coefficient, when you're factoring out the GCF, you want to factor out the negative. And so we put minus 5. And then minus 5 times what number is 10y? 2y. So far, so good. We're hoping that we can end up with a factor that looks like this, 2y minus 3. When I take a negative 5 out of 15, or what number times negative 5 is positive 15, and the answer would be negative 3. So that works out. That's exactly what we wanted it to be. 2y minus 3 is the same as the other 2y minus 3. And now we can write this as 3 times, we can do away with the brackets. 2y minus 3 is our common binomial factor. And then when I take it out of the first group, I'm left with y. And when I take it out of the second group, I'm left with minus 5. And so this, my friends, is factored form. All right, we're going to do another little unit here on the difference of squares. For this, I want you to write this down here in your notes. Write down 1, 4. Let me just take the comma. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Now I hope that those numbers look very familiar to you and that you recognize what their significance is. But I'm going to make a quick table with them. to help you see, hopefully, what this pattern is. Now, this continues on. There are infinitely many of these, but these are some of the most important that you'll see. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. And 10 squared. So those are what are called perfect squares. And so difference, and when we're dealing with this, we've got a difference of squares. And what do they look like? When something is in the form a squared minus b squared, where a and b are perfect square expressions, that should read a squared and b squared are perfect square expressions. The factored form looks like a minus b times a plus b. So what are some things that you should notice about this? 1, only 2 terms. It's just 1, 2. And that they are perfect squares, whether that's in variables like x squared or numbers like 16 or 36 or 49 or 100 or even 1. Another thing you should notice, difference. Remember that in difference, that means subtraction. They are subtracted. And then there's also no middle term. There's no middle x term, which is just another way of talking about the first one there. If there are only 2 terms, there's no middle term like there is in a trinomial. So those are some things you should watch for. All right, x squared minus 49. X squared minus 49 can be rewritten as the quantity x squared minus the quantity 7 squared. So now I have it written as a squared minus b squared. Then I can just factor it to x and 7, x and 7, and then you put a plus in between the one set and a minus in the other set. And it doesn't matter the order. It could have been x minus 7 times x plus 7. All right, let's look at the next one. 9x squared minus 16y squared. So I can rewrite 9x squared minus 16y squared. I can rewrite 9x squared as 3x quantity squared minus 4y quantity squared. Now I've determined what a and b are. A is 3x, b is 4y. I can rewrite this as 3x and 4y times 3x and 4y, and I'm saving the signs for the last just to help you see that these are called conjugate pairs. When you have the same thing, 3x and 4y, 3x and 4y, or in the last example, x and 7, x and 7. But then in between them, you have a plus and a minus. They call those conjugate pairs. So difference of squares factors to conjugate pairs. Difference of squares, conjugate pairs. And vice versa. If you have conjugate pairs and you multiply them together, you get difference of squares. But if you have difference of squares, you can factor them as conjugate pairs. So it works in both directions. Number 7, 25m squared minus 36n squared. So I'm going to rewrite this as 5 squared is 25, and m times itself is m squared. So that's our a is 5m squared minus 6 and n squared is 36n squared. So I'm going to write this as 5m and 6n, 5m and 6n plus and minus. And that's it. That's what that looks like factored. And then finally, number 8, 16s squared minus 36t squared. So I'm going to jump straight into this. 5s quantity squared. Make sure that you're careful with your s's so they look very s-like and not very 5-like. 4s squared minus 6t quantity squared. And so what do these look like? 4s, 6t times 4s and 6t, and then a plus and a minus. And that's difference of squares. Those are, you really want to memorize that pattern so that when you see two terms that are perfect squares and they're subtracted, that you can factor them out in this way, the a plus b times a minus b form. All right, good luck, practice. You can do this.